For part 1 of problem 2, we're asked to show that if we're given a number of variables xi drawn from the distribution which takes on the value p with probability p, and 1 minus p with the remaining probability 1 minus p, each of these variables independent, then probability that x1 equals, let's call it a1, x2 equals a2, etc., through xn equals an is going to equal the product of the an's. Now, there's a couple caveats here. This is only strictly true if each ai is p or 1 minus p. Otherwise, this probability is just going to be 0 because those are the only values any of the xi ever take on. And p is not exactly 1/2. The problem if p is exactly 1/2 is that rather than think of the variable as having probability 1/2 of taking the value 1/2 and then 1 minus 1/2 of taking the value 1 minus 1/2, we would probably combine those two and say this variable actually has probability 1 of taking the value 1/2, and that will mess up the reasoning. So this is just a minor error in the way we worded this section of this problem. We really should have worded it more carefully, but our loose wording has these caveats coming in. None of these make any difference for what we actually intend to do with the results further down the line in this part of the homework, but for the very first part of problem 2, these caveats are minor niggles with our wording. Anyway, how do we prove this? Well, first observe that the probability that xi equals a sub I individually is a sub I just by the definition of the distribution of x sub I. It does have probability p of taking the value p, and it does have probability 1 minus p of taking the value 1 minus p. Its probability of taking either of the possibilities for a sub I is equal to that particular value of a sub I. Okay, what's left is just applying independence. The probability x sub 1 equals a sub 1 and x sub 2 equals a sub 2. Maybe I should write with this wedge. And x sub n equals a sub n. Well, by independence, this is the product of these individual probabilities which, by what we've just seen a second ago, is equal to the product of the a sub n, as we were supposed to show it was equal to. So there you have it. That's all there is to it.